asking him the questions. Feel free to drop your questions in the comment section, and we hope to be done on or before 7 o'clock. If not, would ask for another 10-15 minutes and see how it goes. All right, Daniel, over to you.
Thank you. We will very much try to keep us on the 7 o'clock mark. Hi everyone, I am Daniel Adeomi. I am a product manager at D49. I think Chegoz's intro covered largely anything you'd need to know about me professionally. I live and work in London, and I like to meet people, talk about things, including, I don't know, APIs, product management, and that's what I do. Why are we here today? We are here to talk about APIs. APIs stand for Application Programming Interface. I doubt that after having just said that, anyone would really remember it for the rest of their life. You don't need to cram the meaning of APIs. If you want to know the Application Programming Interface, and what do APIs do? They're a very important part of the internet as we know it today. They allow different software systems to communicate with each other. One of my favorite analogies, analogies that helped me to understand what they are or how they work, especially like when I'm talking to people, is there's this kitchen analogy of imagine the internet as a restaurant. And APIs are the waiters in that restaurant, as you see in this cartoon that I have here. The client, being you, comes into the restaurant and needs food, being whatever that is. And the menu represents all the things that you can get from the restaurant. So from the internet, all the things that you want to do on the internet, you want to check, football scores, or you want to, check what the weather looks like. That's what is on the menu. And the API is responsible for carrying, the instructions. You come in and say, I want to eat rice. And the API is responsible for going to where the rice is to, get them to make you rice. Think of this restaurant. In this restaurant, the kitchen is the server. The server being where business logic lives. You see that I labeled the chef as business logic. In this analogy, business logic is what does what you want it to do. So who's responsible for cooking the rice that you want to eat? In an API example, who's responsible for, what is responsible for calculating, the price of gold or the price of Bitcoin? That's the chef, the person in the kitchen or in the server cooking. And the API is just responsible for running all of that information to and fro the person that needs the information or the application that needs the information, and the person that does the thing, the person that's responsible for feeding that information. I've always just liked the analogy, largely because I like food, and also because it makes things very clear to me or for me. And there are many different types of APIs because there are many things that you can do on the internet, either as an individual or either as a business. Every business, every tech business or software-enabled business has their place in this whole internet ecosystem that we are. And so therefore, there are many ways with how they use APIs or what APIs mean to them. There are internal APIs, for instance, which means you want to do something. Think of everything you want to do as a service. You want to do something, you can decide to build functionality to do that thing, and then allow your systems to talk to each other via internal APIs. There are also partner APIs, which are APIs that do something that you want, but are provided by another company or by another organization, by another quote unquote major player on this internet ecosystem. And so that is when you'd find, for instance, Uber doesn't need to build a map. They can use the Google Maps API because Google already did all of the work required to build out maps. But Uber needs maps to ensure that the app works. And so they don't have to build an internal API. As an example, they could do partner APIs. And then there are public APIs. Public APIs are largely APIs that people like you and me, the peasants of the internet ecosystem, get access to. I also, for instance, using Google Maps as an example, I want to build my own test app, or I just want to play around with what is possible but I need Google Maps, I need an integration. I could find, a public API that provides that service to me. There's a little bit of a distinction between partner APIs and public APIs, because those two APIs are external facing, and partner APIs are just the ones that you build knowing that there's some sort of business agreement, there's some sort of there's some sort of structure around. There's usually structure around all external facing APIs, but with partner APIs, you're building it customized to how that person might need it, or how a fellow internet organization might need it. Whereas with public APIs, you're building it you're building it assuming that the people using it are either individual developers or individual players in this whole internet thing that we're doing. Those are types of APIs structured internal facing / non-internal facing. There are also like API frameworks or API types. Frameworks is all synonyms. The most common of them, I think, is the REST APIs. So representational state transfer. I think that something like maybe 80% of the internet, or maybe 90%, I don't know what the number is, I'm just calling numbers, but a good chunk of the internet uses REST APIs. And REST APIs are HTTP APIs. HTTP is Hypertext Transfer Protocol, which is the protocol that is used by all of the internet. You have your URL links and it's prefaced by HTTP, and they use that same method of communication. And these are these REST APIs are what you see, when you want to log into your Google or Facebook accounts, when people like Stripe provide you with a public API access. Everyone uses REST, and it is kind of self-fulfilling in popularity, because the more popular it is, then the more people have to build to it, because the less people know about how to use other APIs. It's kind of like this whole cyclic thing. With REST API popularity. There are also what we call SOAP APIs, SOAP being Simple Object Access Protocol. I've never used SOAP APIs, but I think one of their main distinction is that they use XML as their data format, and as a result, they're a lot more, they're a lot stricter than REST protocols. This is why you find them in highly regulated industries, places like finance, banking, healthcare. That's not to say REST APIs are not strict or cannot be formal. I work in a highly regulated industry and we use REST still, but SOAP is just built particularly for use cases such as that. There are also webhooks, which you can think of as reverse APIs. And the reason why they're reverse APIs is instead of you having to send something to them and get something back, webhooks, they're just always sending something to you. So think of it like APIs that never stop talking if they have something to say. And this is what works when you get a notification from your app, or when someone buys something on your platform, you send them an automatic email. If you think how it works under the hood, like if you're getting notification, you didn't have to perform an action. You didn't need to tell it what to do to send you, that notification. That's how webhooks work. They send information, based on certain criteria that you define. There's under webhooks, there's this other thing called WebSocket. And the difference between a webhook and a WebSocket is webhook information transfer is in one direction. WebSocket is two-way transfer. But the important thing about them is they automatically send data when an event happens. And the last of the frameworks I think that I'll touch is GraphQL APIs. And GraphQL APIs are used for when data transfer needs to be specific. So they're very customizable and they're very flexible. And unlike REST, where you want, a table of X, X, and X, for GraphQL, for GraphQL APIs, you can define exactly what you're looking for. So, for example, when you have you pull up your Facebook, page, and you need to get, user profile, you need to get posts, you need to get comments at the same time, because you're displaying all of that information at the same time, and you need it to work. Like, you need it to be performance. Performance meaning that it doesn't need to take 10 seconds to load. You need it to work, and you need that data to come in one go. GraphQL APIs are usually particularly good for that. I think Facebook uses them a lot. I don't know if they developed them. I think I might have read or heard somewhere that they might have developed GraphQL as well. But yeah, those are common API types. And now let's talk about the anatomy of an API call. You might guess from my slides that I like visuals. It's how I guess understand these things. And when you think of an API call, there are different parts of what is happening behind the scenes. There's a client request, there's a gateway, there's all of the backend processing that happens, and then there's a response. And if we are going back to the restaurant analogy that I used before, I mentioned that the APIs are the waiters in the restaurant. So think of everybody that comes into this restaurant. So quote unquote, every user of this service or every user of the internet needs to make a request. And so the waiter sees them and says, "Hey, hi, welcome." Goes to your table to ask, "What would you like from the menu?" The menu being the HTTP methods that are available to you, either a get, post, put, or delete. These are REST request methods, by the way. If you remember, we said REST uses HTTP protocol. So the menu being you can get, you can post, you can put, you can delete. The API is asking you what do you want. So you see in this example, this woman is like, "Oh, give me rice and I don't know, chicken," and then the API or the waiter is responsible for going back, to where the service does the job, where it does the thing to get them what they want. I don't know if anyone on here has seen this show called The Bear. Has anyone seen The Bear? It's one of my favorite shows. The Bear, yes? No? Okay, one person has seen. All I need is one person. So in the show called The Bear, there's this guy, Cousin. And Cousin's job towards I think season 2 or season 3 is the general manager of the restaurant. So his job is almost literally to stand at the door of the kitchen and take the orders from the waiters. So someone wants rice and someone wants chicken and someone wants turkey and someone wants goat. He's taking all of those instructions from the waiter and he's passing it onto the kitchen, the guys back in the kitchen, the chef cooking. He's telling them, "Okay, give me 1 turkey and give me 4 goats and give me 2. It's chaotic, but like he's in charge of the flow of information from the waiters, the APIs, and the kitchen. And that is what an API gateway does. It handles authentication, it handles rate limiting. I think rate limiting, the name itself is pretty derivative, which is it limits the rates at which information, in this case, API calls, are coming in. It logs all of this information. So it's taking notes on the paper, 1 goat, 1 chicken, 1 turkey, 1 rice. And that's what an API gateway does. And then in the kitchen, where all of the magic happens, where all of the cooking happens, is where you have, the backend processing. When you see what business logic, it means, like, for instance, if you have an API that converts Naira to dollar, the business logic is the algorithm that says 1 Naira equals $1.29, etc., etc. All of that mathematics and an algorithm that washes the numbers and gives an output. That's what you call business logic. And all of this business logic is handled by microservices. Microservices, think of them as different chefs in the same kitchen. One chef is skilled in cooking goats. Another chef is the guy skilled in pastry making. Another chef is the one in making swallow and soup. And they're all microservices. So if you need amala, I don't know, and begiri, the guy at the gateway, so the API gateway, decides which chef is best placed to handle that request. So he knows to give it to Chef C because Chef C is the one that does swallow. And he knows if he wants goat, he gives it to Chef P because Chef P is the one that handles, I don't know, roast meat or something. And that's basically how it works behind the scenes. And when all of that food is prepared, so when all of the business logic request has been handled, the API then brings back the response to the person that requested, the client. That's what it's called. So it brings back the response to the client. In this analogy, the response is food. So you asked for 4 plates of, you can see this guy, I don't know why he has a lot this amount of food here. He's not waiting for anybody. He's eating by himself. But let's just assume he's a big boy and he likes big food. The API has brought and delivered all of these responses in the exact same format that he did. Now and again, you would have gone to a restaurant where they're like, oh, sorry, there's no goat. There's no goat is goat not found, or in this case, error not found. Sorry, not resource not found, or whatever you're looking for is not found. That's, for instance, an error 404. If you get what you're looking for, it's an error status code is 200. If you get a 500, it means the chefs have decided that they don't want to cook today, and there's nothing we can do about it. That's like a server error. It means there's a an error with the whole server, with the whole kitchen. This analogy. This is just, I don't know, a very simplistic understanding of what goes on behind the scenes when you make an API call. Let us see. There's more. So remember, when we're still talking about REST, by the way, talking about REST APIs once again, because a good chunk of the internet is built on REST architecture. And so every resource out there these days is designing for REST, except for very specific cases like we already covered with GraphQL or with SOAP. There are 4 very popular request methods for REST. There's a 5th one that is also popular-ish, kind of like, not quite popular, but let's just say like he's part of them, kind of. And the way I like to explain this to people is, imagine a table. You don't have to imagine. There's already a table here that I made. There's a table, and think of each row. So this is, the rows are what? Row and column. Yeah, sorry, that's my big age. I still need to do this to know what a row and column is. So the rows are the horizontal ones. So think of each one as the row, and think of each of these as the columns. We will call every row a resource. With APIs and databases, each row is referred to as a resource. And the job of a post HTTP method is to create a resource. So you're creating a new row in a table. That's what posting does. If you're getting, it means you're requesting for information about a resource. So you're saying, give me everything that you have in row number 1, ID 1. Like, I want to know who is on ID 1, and I want to know what his age is, and I want to know what state he lives in. That's what a get does. So post creates, get extracts. It doesn't remove it, it just reports it. Because using the word extract, I'm trying to be clear that you're not removing anything from the table. You're just telling the API to tell you what they have. It's almost like telling the waiter, go to the kitchen and tell me what you people have. Then there's the put request, and the put is updating a resource. So I think with REST, one of the good things about the terminology is they try to be as reflective of the intent as possible. When you say put, you're putting in a resource, so you're updating a whole row in this example. So if, for instance, Luke is no longer 45 years old, is 46 years old, and his state is no longer Akwa Ibom, his state is now Delta, you will send in a put request to update the whole resource with this new information. And patch is one of those interesting ones where it is kind of like put, but not quite. So what patch does is it updates a specific element, a specific object in your resource. So if the only thing that changed about Luke is his age, then you could patch and just update the age element in that resource. That's what patch does. And then there's delete. Delete removes a whole resource. So if, I don't know, John's enemy has died and you need to clear him from the record, just delete. That's what happens when you when you click delete account on, I don't know, your app, Facebook or wherever, it goes into the database, their user database, and it removes all of the information about you in that same row. And that is how it works with HTTP request methods. There's, as part of it, I mentioned with APIs that even with internal facing APIs and with external facing APIs, either partner or public APIs, there's always a level of what's the word I used then? I can't remember the word I used, but there's always a word of secure. There's always a level of security that needs to be attached to API usage. I like to think of them in two ways. One, access control, and the other one, controlled access. Um, Access control means you're controlling who can get your APIs, like who can, that thing that you're cooking, who can order your food, basically. And controlled access is basically how much food can they order. We saw that guy on the table with 6 plates of food. In a controlled access environment, he might be limited to 3 plates of food. But we'll go through what these mean. One of the most common, most important ways that APIs are secured is by using API keys, particularly in the case of public APIs. API keys, an API key is simply a token, a literal token of numbers / letters that everybody that makes a request from the API is assigned. And the reason why you assign that key is so that you know, oh, this guy has come back again. He's asking for the same thing. It's basically authenticating who you are. There are 2 words in particular that you see over this page, which is authentication and authorization. Authentication is just proving who you are or proving that you're a person in the first place. Another way that APIs are authenticated and secured is by OAuth. OAuth stands for Open Authorization. The 2.0 there is just the framework version. And this is when an API does access control by exchanging tokens with another service or another client or another application. And it is largely used for authorization. It is essentially for the API to be able to say, this person is allowed. Not that this person is who they say they are. That's someone else's job. But like, this person is allowed to be here in the first place. There's also JWTs, so JSON Web Tokens. I don't know if you've come across the acronym JSON before. It stands for JavaScript Object Notation. It's just a way of presenting information that makes it readable to, slightly more readable to a human. And JWTs are compact tokens that are used for authentication, but they are different from API keys in the sense that they contain all the information that you need about a user. The way I like to think about it, especially in my restaurant analogy, is like an ID card for the waiter. So imagine if there are so many waiters in the restaurant that the restaurant needs to know that people are not just standing up from their table and going to the general manager and asking for food. So every waiter has to have a name tag, or in this case, an ID card on their chest. The JWT token is that ID card. And the reason why it's different from an API key, think of an API key as a safe word. So if at the beginning of the shift, the general manager said, everybody that comes to order food from me today, I don't care who your client is, you have to use the word please. If you don't use please, I will assume that you are fake and you were not here when we were doing this meeting. Therefore, you are trying to order food abnormally. That's an API key. Every waiter that comes will say, please, cousin, can I get 1 goat? Please, cousin, can I get 2 chickens? But a JWT is an ID card. They still have to say please, but the reason why it's different from an ID card is the manager does not need to remember who has said please or was like, all he needs to know is that there's an ID card, and because this person is wearing an ID card, a JWT in this case, then they're allowed to order food. And then rate limiting and throttling. It is largely, especially for public and for partner APIs, it is largely to limit the amount of strain that people can put on your APIs, or especially in your business logic. Like if you think about ChatGPT, for instance, like every request that somebody makes to ChatGPT costs the company a lot of money. And so they have to make sure that like people cannot make a billion requests a day. Otherwise, they'll be losing more money than they already are, and they're losing quite a bit of money. But it happens a lot with public and partner APIs where you have to limit how many people can make a request. You have to limit how fast they can make those requests. In restaurant analogy, how many plates of food can one person buy? I'm very sure I've been to restaurants where you're not allowed to order more than X or something. Maybe not restaurants, maybe more like supermarkets or something. That's what you call throttling or rate limiting in this case, as an example. And if we do a quick like UBB, the other example, so that all of this goes away from the theory. And I know I've tried to make it practical by making it restaurants analogies, but nobody will go to work tomorrow and tell their developers that API is a waiter in a kitchen. So let's try to make it a little bit more tangible. This is a typical API request. Don't get, what's it called? Don't look at these numbers on screen and be like, oh my God, like, I don't know what any of this means. Neither do I. But I can tell you the parts that I do. These get, we already spoke about HTTP method. Get is the HTTP method attached to this. So you're essentially saying, get this, whatever this thing means for me. Now, this HTTP api.weatherstack.com, that's called the base URL. That's where the API lives, essentially. I'm basically trying to get something from weatherstack.com. Follow the thoughts. First of all, I'm trying to get. Now I'm trying to get something from this person. And you hear, I'm sure when APIs are involved in conversation, you usually hear the word endpoints. What does it mean? In this URL, it says /current. /current here is the endpoint. So if you think of it as, when I made the analogy of the business logic, of the kitchen and the general manager redirecting business logic. Imagine a restaurant where there are multiple kitchens. You're telling him, get it from kitchen A. You're telling the waiter, I want goat from kitchen A. I don't want goat from kitchen B. You're trying to be a lot more specific about where you're getting information from. And that's the resource you're trying to access. That's what you call an endpoint. And every other thing after the question mark is called a query parameter. And a query parameter can have multiple elements in it. If you see here, it has an access key in which I spoke about, which is an API key, and it also has a location, which is another parameter. And this could be anything depending on the URL you're trying to get something from. After having made this request, I did this as an example, and this was part of the request I got back. I got a 200. So the fact that something came back means my request was successful. Largely, in most cases, that's what it usually means. And the information presented here is an example of that response. I'll try to make it a little bit more real, because I know, especially for me as a product manager, you think API, posting, getting, like, where is all of this tangible? It makes sense, maybe it doesn't make sense, maybe not. But especially as product managers that are trying to work with developers or with a development team, or you're trying to build API that powers something that drives either an application or that drives something on the internet. This, I think, might help make this a little bit more tangible as an example. When you get, so I've made that get response to the weather API, and they gave me all of this. Now think of a weather app. If somebody, a product designer or a product manager, decided, I want a weather app and I want it to have exactly all of this on this page, the response I made to that API is what powers the information that is present on this screen. And exploring or investigation or checking the API and its responses can let you know what is possible with what you want to do, either as an internet application in this case, in this example, or just in general. It's like, can this API answer the questions I need it to answer? What are the questions I need? I need to know the city. You see that the response you gave me city. So I know, okay, because I have city, I can have city here. And it's the same thing. I just try to map all of the information here to the API responses that shows that the API response in this case is what powers what eventually gets to the hand of the user. And as product managers, what you're really concerned with is what is in the hands of the user. What usually happens is, a lot of product management or typical product management day to day starts from kind of this side of the process, doesn't consider everything we've spoken about in the last 10 minutes. And this is where it starts from. But I think learning how these things work under the hood helps you to design for feasibility, or design for performance, or design for skill, whatever it is. It's like, if you don't know whether an API can solve your problem, you don't know whether that problem can be solved. And nobody wants to tackle a problem that cannot be solved. So this is just another example to make it a little bit more real. I think I went into a bit more detail. You see where, the whether app has wind direction. If there isn't an API that already services wind direction, as an example, I might have to build one that calculates wind direction to solve my own problem. In which case, a partner API might not work for me. It might have to be an internal API, etc., etc. These are just examples. I hope that over the past 15 minutes now, I have managed to cover just enough about APIs that makes it a little bit clearer what they do and how they work, and maybe even how they influence, the work that we do as product managers. But yeah, that's about it from me. Thank you very much. I'm going to stop.
Yep. I like the reactions already. Like before I even say anything, you all are already giving the reactions. I love that. So it shows that we all learned something. Yes. Cool. I like that. Okay. We will take a deep dive into the questions now, and then we would have our next session. Just give me a minute. Can you confirm that you can see my screen?
Yes, we can.
Oh, cool. So once again, please, I hope we took notes. I hope we are able to take down some questions. So feel free to drop your questions in the comment section as I ask Daniel a couple of questions. So let's dive right into it. So Daniel, what inspired you to specialize in APIs, and what excites you most about working with them?
I'm sure there are some people that when they were growing up and they asked them what do you want to do, they said I want to work with APIs, but I'm not one of them. What inspired me specializing was a necessity. I started working on a product that was where the technical bits were just way over my head. I got in and I struggled more than I would have liked, and so in order to have done my job with any sort of, to have done my job properly, I needed to know about APIs. So I wouldn't say I specialize in APIs particularly. I just, necessity called for it. What excites me about working with them is the amount of stuff that I don't know yet. It's almost like you see all of this. Yeah, the amount of stuff I don't know yet makes me curious, and I think curiosity has been very important to me as a product manager, or is still important to me.
Interesting. So curiosity. Okay. All right. What are the key considerations when designing an API for a product?
I think when I was talking about the weather example, or the weather app example, something I covered is can this API solve the problem I need it to do? So when you're designing an API, you need to start from what you want in the hands of a user, and then work your way backwards. And then you also have to think about those are functional things. You have to think about other non-functional things. Like you have to think about the security. Is this API going to be internal? Is it going to be external? If the API is for me, I can let go of a lot of things and just hope and pray to God that it doesn't get into the hands of the wrong person. It's fine. But if I put it out on the internet, I have to, work to make sure that if it gets in the hand of the wrong person, because it's the internet, I'm not calling any of us the wrong person, but likelihood is there will be a bad player, and you have to consider when designing an API, you have to put in proper security, proper authorization. I spoke about controlled access control. Make sure there are keys. Design for statelessness. That's something I'm not sure I covered in detail. There are all these things designing an API, but I think largely is for functionality, exactly what you need it to do. And two, if it's a public API, design, for what public APIs need to be able to do. And it's an internal API, designed for it to be able to match your systems and functions. I mentioned the GraphQL example. GraphQL was created because a company couldn't find APIs that worked the way they needed it to. And so they went to the drawing board and they built their own. That's a bit extreme, but I hope that answers that question.
Yeah. Okay, so the next question is, what are some best practices for ensuring API security and preventing unauthorized access?
Require an API key. require JWTs if you need authorization. Talk to your developers also. I don't think that is, yeah, because I'm saying all this, I'm giving all these answers. This is what maybe as a product manager in my example, I would go to them with and say, but like the developers know a lot more than you do when designing for API best practices. Usually, design for rate limiting, make sure that putting the API out there does not will not bankrupt your company. I think this question in particular I covered enough in the talk.
Okay. What are some common mistakes that you see companies make when integrating APIs into their products?
Yeah, this happens a lot with partner APIs. I'm not sure that it happens with public. If your company is using public APIs and they are making mistakes, somebody's doing something wrong. But with partner APIs, yeah, I say public APIs because like you're using APIs that 1 million other people are using. It's very possible that they find a way to backdoor or do some attack DDoS, whatever it is. I don't know. But if you're talking about partner APIs, which is usually between companies as well, there's a not very common mistake of companies tying themselves to APIs that don't match the filter from the vision for your product. So think for an example, Google Maps, or maybe Google Maps is not a good example. If you want to design a weather app, and today, like as an MVP, all you need is for the weather app to tell you whether the sun is out or not. But tomorrow, you want it to be able to tell you exactly what time of the day is going to rain. And then you go ahead and tie yourself to that API. Chances are when it gets to tomorrow and you need it to tell you exactly what time of the day is not going to rain, if that company doesn't think that it is important to them or for them, then you don't get the vision of the products that you were looking for in the first place. So there has to be some sort of a match between, to make it very practical, the roadmap of partner APIs and your vision or your roadmap. In functionality, there has to be a match of like what you will be able to do eventually. That's a common mistake because people get short-sighted. You just want to implement something today, and that's all well and good. And I think another important mistake, sorry, I'm trying to be quick here, is optionality. If you design, so usually you would define your requirements and then get an API and then tie yourself to it. But now and again, you find yourself in a case where you get an API and you're like, you know what, whatever the API can do is what will make our products do. And then you're designing specifically for that API or the functionality that that one can provide. And what happens then is you don't have optionality anymore because you've kind of boxed your product or your vision into only what the API can do. I think it kind of ties back to what I was saying before, but optionality, it comes across in many forms. That's just an example. And future functionality, I guess, are two things to watch out for.
Okay, optionality and functionality. All right. How do you see the role of APIs evolving with emerging technologies like AI and blockchain?
There's this cool thing that's happening now. And I make the jokes all the time. At some point, my AI will be talking to your AI. I say that because like I've been in a couple of meetings where somebody's note taker is there and another person's note taker is there and third person's note taker is there. And God knows what all the note takers are saying to each other. Right now, they're not saying anything. But I'm very sure, like I said, the internet is full of APIs. APIs power the internet. And AI is taking us to, I don't know, a world where we don't need to go and sit down in the restaurants to consume the resources. We can send the API to do the work for us. It's happening now with ChatGPT. You tell me the 5 biggest things in the world. And it goes out and does all of that search for you through an API and it brings back the results. But what's happening now is you can tell your phone to do that, and then your phone tells ChatGPT, and then ChatGPT tells another API. And now you have all these APIs talking to each other in an internet economy where humans don't need to be involved anymore. Like you want to book a flight, just tell your phone to book a flight. You don't need to open and approve payments. You don't need to, check the pin code. You don't need to do anything. Their API is talking to your own API, and that person's API is talking. And APIs right now are designed for, you know, interacting with each other. Things like the rate limits that work with human interaction will not work when APIs need to talk to each other without human interaction. That's an example. APIs will have to evolve essentially to a world where humans are left out of the internet economy. And I think like it will only happen with APIs. There's this thing now called MCPs. It's a popular thing in AI now where you're trying to get, you know, an agent. So this internet agent, so you use AI to create an agent, and the agent performs a specific task. But in order to perform that specific task, it is talking to another agent or another API. And if what you have are all these agents, so MCP is an example of how AI is changing how APIs work, because people are now designing APIs for APIs. If that makes sense. The blockchain, I know a lot less about, but yeah, that's what I think.
Thank you for that. Okay, so in your bio, it's written that you have a certificate in technical product management. What led you to actually pursue a certificate in technical product management, and are you considering a career in that field?
Like I said, it was a necessity thing. I was already in a role that was very technical, and it felt like I was way in above my head. And I did the course, and it was very, very good. And at the very least, what it started is a journey of, like I said, curiosity is important, but a good blocker, an important blocker of curiosity that people don't talk enough about is sometimes you just don't know where to start. Like you want to learn, but you don't know where to start. But if, for instance, like by virtue of people being here, just even learning about APIs, then you start having questions like, oh, I wonder if there are other request methods more than these 5 that this guy spoke about. And then you go to ChatGPT and like find answers. Like it's things like that. So the technical project management course kind of kickstarted that for me. Will I take a career in that field? If they would take me, I guess. Once again, I didn't grow up saying, no, I want to be a technical program manager. I want to be a doctor.
Well, you're a doctor in products.
Yeah, I am now. Well, thank you.
Okay, all right. Everyone, so to speak to this certificate that he took, it's actually the Product Dives Technical Product Management Program. He went through it last year, right? Yes, last year actually. And so I've spoken about it earlier about I'll talk about it a bit since we have more people on the call. It's a program where all these things that he has taught on, trust me, there's actually a class dedicated, a whole day actually of a class dedicated to teach on APIs alone, right? Amongst other things that you'll be learning, like the microservices, performance tooling and optimization, software testing, introduction into what it even means to be a technical product manager, and also system design. All right. So you'll be learning on all of these things. Okay. So please, if you know that this was exciting for you, if you know that, and as I said, being curious, you know, you want to learn more, you want to be able to solve the problems in your space, in your job, right? Sign up for this. It starts this Saturday and you'll be better for it. All right, let's move on. How did taking Productized Technical Product Management Program impact your career growth?
For one, I'm a lot better at my job now. Gives you some sort of credibility. And it's, I guess the value is exponential. Because I'm better at my job, now I can do more things. And because I can do more things, for instance, I imagine I'm on a path that I otherwise would not have been before. I haven't taken a different job or a different role that is specific to this, but like I said, it makes me a lot better right now, and I expect the value to be exponential.
Interesting. That's beautiful. Okay. What technical skills do you think are essential for a technical product manager?
Depends on whether or not they started out technical. If they started out technical, then they're fine. Like you need the other skills. If you didn't, curiosity is a big one. I find myself falling short of it even still till now. But you can't stop wanting to know, wanting to learn, especially knowing that as a technical product manager, what you're doing is you're supporting people that are a lot more technical. So you have to be willing to to be curious. And the reason why I say curiosity is curiosity leads to learning, and learning leads to understanding, and understanding leads to clarity of communication, especially. Your job as a technical product manager is to bridge that divide between what is possible, what is feasible, and what people want, what the business wants, what's good for the business. And you can't be clear to the salespeople, you can't be clear to the CEOs that are non-technical, you can't be clear to people that have no idea what all of this means if you don't understand it fully. I had to break it down into the basic. Like I'm using this kitchen analogy to describe APIs. I had to break it down for myself, even more bare bones than that. And you can't do that for other people if you don't understand it. Because that clarity of communication is one of the most important skills as a technical PM. And then you also have to have an eye for systems thinking. It's one thing that's important with like building technical products is there are so many moving parts. There's so many systems talking to each other, and you have to be able to make decisions that consider everything at the same time. Some people are born with it and it's innate, which is all well and good. But if you're not, like, it's fine. It's just another skill. You need to be able to, every time you're presented with your technical feasibility or functionality options, you need to be able to take a step back and think how it affects everything and how they work together, including the profit and loss of your company.
That's the business side of the company. Yeah. Okay. Hi, everyone. So I see that it's already 7:04. We're sorry for taking your time. So what I will just do is I'll just ask the questions in the chat section. Are we fine? Please, are we fine if I can just take like 10 or 15 more minutes for us to just round up, everything? I need reactions to know that we're good. Oh, fantastic. Thank you so much, guys. I'm so grateful. Okay, so let me speak to the questions in the chat section, right? It says, Sakas Montreal says, do you think product managers should be able to test endpoints?
Should they be able to test endpoints? The answer is no. Will their lives be a lot better and easier if they know how to test endpoints? The answer is yes. So I guess depends on how easy you want your life to be. Like if you had to get somebody to do it every single time that you needed to, probably fine, especially if you have the resources, like if there's someone that's always available. If not, it doesn't hurt to know how to be able to test endpoints. I really do. I know how to, but I really do in my day-to-day. But I know that if I needed to, I'm not going to be my own blocker, if that makes sense.
So it's almost like know it, but it's not like a criteria.
Yeah, it's a nice to have.
It's a nice to have, exactly. Okay, so Motirai, I hope that answers your question. Noah Oluwabusola says, does every process in a product, whether app or web, require an API?
It depends on how you build your app or website. Many processes require it. In fact, most processes do. But there's this whole thing about trying to make your app or your website performance, or you're trying to be cost effective, or just be general, like data effective. So everything might not require an API, or everything might not require APIs in the same way. But you can't, like most of them do. Pretend as if everything does, and you'll be at least fine.
Okay, so the person also says, when a PM is required to write down an API requirement document, how will this be done? This is a huge one, and I will just say that you should just sign up for the technical products management program, because you'll be taught on this. Okay, your question will be answered on this. However, Daniel, you can speak to it.
Yeah. If they are not a technical product manager and someone says they should write the API requirement doc, there's a mismatch of capability and I don't know what is needed. But if you're just a product manager, not a TPM, and they say you should write your API requirement doc, please get your developers involved. Like they will always know what is possible and what is reasonable more than you do, or you can. All you know is what you want out of the product. There will always be the clarification, like you said, from the engineering team. Are there any APIs to study on? If I have resources on APIs, there are a lot of resources on API. Can I share? Maybe I'll look for a bunch. Maybe Shia Goze can share, or find a way to do so.
Yeah. Okay, so Claudia says, how can I improve my knowledge on API as a PM? Are there any specific resources you can share, which you have actually answered?
Okay. Yeah.
Okay, so Adewale Sanusi was responding to someone. Okay, Amina says, is it the PM's job to create API documentation? And then how can she join your Young PMs community, the one that is in your bio?
Oh,
So that Amina was here from the very beginning.
Yeah, sorry. That's young people in tech. How can you join? I'll find a way to get across. Given that that's not the topic of this session.
Okay.
Is it PM's job to create API documentation? It can be. But like I said, if anybody is leaving the PM to create the API documentation by themselves, especially if they're not a technical product manager, there's some sort of mismatch. And the way to bridge that gap is get other people involved, get your developers involved. You don't need to create an API documentation by yourself if you don't know how to. And even if you do know how to, you still need to get them involved anyways. So you might as well. At least that's my opinion on that, really.
Okay. Sorry, I'm trying to go through the questions so that I don't miss anyone. Emmanuel says, please, are there different types of product managers because you're kind of specific on tech? Yes. Okay. So Emmanuel, we're specific on technical product managers because this webinar is actually centered around the technical product management program. And so that's why we're speaking to it. Okay. I hope that answers your question. So I'll just take like 2-3 more questions and then we'll call it a day. Okay, Daniel is responding. Okay. I just wanted to be sure. Okay, I think you already spoke about this earlier in one of the answers, so I'll just skip this. Do you want to answer this one? What's the key difference between the product manager and a technical product manager?
Yeah, I think I might have spoken on it before. That's so with the technical product manager, there's an expectation that you know how things work under the hood, and therefore the decisions that you make on behalf of the business or the decisions that you make to drive the business are a lot more informed. So you expect a technical product manager to also think about feasibility. With a product manager, they're usually fine to outsource feasibility. And by outsourcing feasibility, I mean like when they come and they say, build this product, you look at it and you do all the user drawings with your designer. And then what you typically go is ask your development team, is this thing possible? But with a technical product manager, for instance, you might not know exactly how much of it is possible, the nitty-gritty, but you should know if it is possible, given what you have, given like there are just little differences, a general product manager and a technical product manager. And because we are moving into a world where product managers are now expected to be able to contribute to building. And by building, I mean like getting a product up from the ground. Like it's not just writing documentations and talking faf or doing webinars like this. It is actually, helping the products come to life meaningfully. It might not be writing code, it might be architecture, it might be system design, it might be whatever. Those expectations fall to a technical product manager, not necessarily to a general product manager.
Okay. How do you collaborate with engineers and other stakeholders effectively?
Effectively. Such a loaded word. I collaborate to the best of my ability. How do I make it effective? Prioritize clarity of communication. Prioritize making sure that when you say something to either your engineers or to your stakeholders, to your colleagues, to your consumers or customers, what you said is what they heard. And this takes form in many cases. Like you could have on, a a marketing campaign and what you're saying is not what people are interpreting. You could be talking to the sales leaders that says this thing is a might and they are hearing this thing is a will. You could be talking to your engineers and you're saying, I want this circle 100, and what they're saying is, what they're hearing is you want this circle 1000. The way to bridge all of those communication gaps is to make sure your communication is clear. Like whatever you have to do to learn how to write, talk, communicate very, very clearly, like do. I'm saying it because I'm also, fortunately or unfortunately, in the same process of trying to close that gap as much as I can. And that has been by far the most useful leverage point, which is if I focus on my communication, most of all my problems will go away, especially with collaboration.
Okay. All right. Final question I'm going to take for this. Oh, sorry. No, second to the last question, because there's one question in front that I want you to answer. What are some key API related metrics that product managers should track?
Track how many people are coming in, whether it matches what you expect. Track how many times one person is coming in, whether or not that's what you expect. Those two, by the way, are other ways of saying track your rates. So rate limiting and throttling that we spoke about. Keep an eye on those. Keep an eye on performance. Things like, I know we didn't go into detail, like latency. How long does my API take to return a response? Especially if your APIs are powering like, internal services, which are important, or they're public facing, which means like people will leave you and the APIs you have to provide if it takes you 2 seconds longer to give them information than another person, because it adds up, especially in this internet world. Like people are loading 1000 pages, 2 seconds times 1000 is a ton of seconds. But yeah.
Oh, okay. So my final question to you is, if you could go back in time, what would you do differently in your career journey?
I feel like the political answer right here is to say I would have taken the TPM course earlier.
Well, it's allowed, but
there are many things I would have done. Maybe that's one of them. I would have decided exactly what I wanted to do early, but like it's not a regret. It is, you don't know what you don't know, and until you do, you don't know it. I think other things I would have done. Yeah, I would have worked on communication a lot earlier. I would have done a lot to bridge my understanding of things in general, curiosity a lot earlier, which maybe I'm working myself now into saying I would have taken this course a lot earlier. Or other courses, for example. I would really, really prioritize. I think this is important for everyone. So like really, really prioritize knowing how to do things and understanding how to do things over, oh, I can do it, look at me, blah, blah, blah. Like do the work and do the work well and know how to do the thing over signaling that you do or over making noise or whatever else it is. I didn't do that early in my career, so I want to go back and change that, but I'm just saying it's an important lesson.
Okay. Thank you so much. I see some people say that they've joined, they don't know what to do next. I'm guessing that someone in the group will grant them access soon. Eugene, the community manager would share the playback with us for those who were able to register. Welcome. Quite a number of people have asked questions earlier and we've answered them. So unless you have a question and we missed that, please point us to your question if you've not asked it, or if you asked it earlier. But if you've not asked it, please can you type in the chat within the next 30 seconds or 1 minute and we'll address it. In the meantime, I will just speak once again to the program itself. I'll just speak to the program itself. Yeah. So once again, the program starts this Saturday. is going to run for 6 Saturdays, which is 6 weeks. Okay. Class is from in the morning from 9 to 12 and in the afternoon from 3 to 6. So please, if you have not made payment or if you have not made payment, kindly make payment